Okay, so now we're on video 312. That is the second video for our first standard. We're still working on determining solutions to absolute value equations and inequalities, and today we're going to be working on solving absolute value equations. Go ahead and make sure you title your notes, and I'll give you a moment to do that, so pause, unpause when you're ready. Okay, here we go. I've got 5 examples that we're going to work through today. Each of them are going to kind of have a little bit of a different look to them. So that's going to give you some help as to how to approach the different types of problems that you'll be working with. The first one, very simple. Let's go ahead and get started. It is the absolute value of 5 minus 3x equals 12. Now, in the last video, we were talking about working with absolute value and saying that it is the distance from 0. So the thing is that there's two numbers. This is representing the distance is 12. So if the distance is 12, then it could be 12 to the positive side or 12 to the negative side. So we actually have to set up two different cases because I could be talking 12 to the left or 12 to the right if we're speaking in respect to 0. So I'm going to say that 5 minus 3x could actually be a negative 12 because it could be 12 off to the left. Or we could have 5 minus 3x to equal a positive 12, 12 to the right of 0. So if my distance is 12, I have to consider it in both directions. Now we can solve these pretty much from the beginning to the end. So we're just going to use, you can use a table if you prefer that. So I could say what happens to x. X gets multiplied by a negative 3, and then a 5 is being added, and I say that because 5 is positive, and the outcome is negative 12. And you can work yourself back up by subtracting and then dividing by negative 3. If you prefer to use that method. If not, you're welcome to just go ahead and subtract from both sides. You get the negative 3x equals negative 17 and x equals 17 thirds. This is one outcome, okay, 17 thirds. The other outcome would be if I subtract 5 and I get negative 3x equals positive 7, so x equals negative 7 thirds. Both of these values, when replaced, will produce the value that has a distance equal to 12. So let's actually substitute those in so you can see what I mean. I highly recommend that you substitute them in for your own sake to check to see that it worked. So here's what that would look like. 5 minus 3 times 17 thirds. The question is, does this have an absolute value that is 12? Does it have a distance that is 12? Well, 3 times 17 thirds is actually just going to be a minus 17. That's 5 minus 17. Does the absolute value of 5 minus 17 equal 12? And the answer is yes. On the other side, I would substitute 5 minus 3 times negative 7 thirds and say, does this have a distance that is equal to 12? And we can check that by just multiplying. A negative times a negative is a positive, and this will be 5 plus 7. And that does have an absolute value of 12. So this also works. Let's try the next example. All right. Here we're going to try the example, and it's going to be an absolute value equal to another absolute value. It doesn't matter what we're saying. We're saying that the distance of one of these is equal to x plus 6, or the distance is equal to the opposite of x plus 6. That's kind of the idea of doing the 12 or the negative 12. So I'm taking the opposite of that. So we still set up two different equations. This side, I can have 4x minus 3 equal to x plus 6. That's this part. Or the other one is 4x minus 3 equals the opposite of x plus 6. So let's proceed and find both of our values. On this side, I'll subtract x, and I'll add 3 to the other side. So when I divide, I get x equals positive 3. For the other one, I have to distribute that negative first. Okay, that's distributing the opposite. Now I can add and I get 5x equals, and if I add the 3 over to the other side, I get negative 3. So x equals negative 3/5. You can check both of these back into the original. Only substitute one at a time. So in other words, if I check this one and I put the 3, I would have 4 times 3 minus 3. Take the absolute value. Does that equal 3 plus 6 in an absolute value? I have the absolute value of 9 equals the absolute value of 9, and it does work. You can try the same thing with the other side as well. Okay, next question. Let's try another absolute value here. This one is going to be the absolute value of 3 over 2x minus 1 equals 4. It's really the same thing. I'm saying the distance of this equals 4, which means it could be 4 to the right or 4 to the left. In other words, it could equal 4 or negative 4. So that means 3 over 2x minus 1 equals 4, or 3 over 2x minus 1 equals negative 4. To get this out of the denominator, I just have to multiply it onto both sides. That's using our inverse operations. To remove something from a denominator, I multiply by the reciprocal, making it part of the numerator. So that means when I multiply by 2x minus 1, that it cancels on this side, but I have to multiply the other side by 2x minus 1. That is 3 equals 4 times 2x minus 1. I'll distribute on the right-hand side, and then I'll go ahead and combine my terms so that I can solve, and x will equal 7/8. For the other side, I'll multiply again, same idea, so I will have 3 equals negative 4 times 2x minus 1. Distribute the negative 4, and combine my terms, so that's negative 1 equals negative 8x, so x equals 1/8. And those are my two solutions, which can be checked if you substitute them back into the original. I got 2 more examples. Let's keep going. All right, this is going to have some operations that happen on the outside of my absolute value signs. For this one, we have to use the inverse operations on everything that's on the outside before we can actually take care of the idea of distance. So I'm going to move all these away. The first step is to add 6. I am not making 2 equations at this point. I can't do that until the absolute value is isolated. So that means that I have 8 times the absolute value of 5x plus 2 equals negative 4. You will not distribute inside the absolute value. You will not distribute inside the absolute value. Instead, I will divide both sides by 8. Negative 4 over 8 gives me negative 1/2. Now, let's consider this right here. This is saying the distance is negative. How do we feel about the distance being negative? Because one of our properties was that the absolute value of any quantity had to be greater than or equal to 0. So at this point, I can stop working, and I can say that there are no solutions. This is my answer. I did not want to draw that conclusion too early, because just because it's equal to a negative 10 doesn't mean that when I use the other operations, I won't end up with a positive value. In this case, it didn't work out that way. Let's try one more. Last one for this lesson is the absolute value of x minus 9 plus 4 equals positive 4. Let's go ahead and continue to solve. I'm going to move this 4 away, because in order to use the absolute value, I have to have it isolated. Now I have an absolute value equal to 0. That means I have a distance equal to 0. The distance is 0. Well, if the distance is 0, do I have a left or a right value? Am I moving to the left or a right? Is there a distance from 0? Yeah, the distance is 0. So in this case, there's actually only one way to solve it, and that's to set it equal to 0. I don't get to use the opposite idea. So the only solution to this problem is x equals 9. Go ahead and try the problems on the entrance slip and make sure that you complete all the practice when we're together in class the next time.